we just saw how we produced a C++ program. What I'll do now is just describe all the different elements of this program in the source code file. So just to show once again how this program got Solution Explorer, and that will just show us what we did. We produced a solution called EXP1. Within that we had a project called EXP1 as well. I could have named it something else, but kept the names all the same. Then we had a source code file, which is EXP1 inside. So this is the basic structure of a C++ program. A solution which can contain many projects. It's a bit of a nuisance at the moment that you have all these layers, but indeed for more advanced programs you can have more than one project within a solution. And also you can have more than one source code file within a solution, within a project as well. But we've just got this 111 at the moment, so it's a little bit of a nuisance in a way, but that's the way it is. Okay, so now let's take a look at all the elements in the program. I'll just run the program again by clicking up here on the Windows debugger. Now we've got here an output of hello world. This statement here is virtually a print statement within C++, so that it prints it to what we call the console, so it's console out. And this is what we call an insertion operator, which doesn't really concern us, but basically it's a print statement. So that prints out hello world. Okay. Now corresponding to a print statement with cout, we've got this here, which is the header file. We call this a header file. It's the IOStream header file. Now basically that contains all the programming for the print statement, and this one here incidentally is an input statement, so they're interacting with the console, so they're input out statements if you like, and it requires this header file. So if you are going to do any printing like this, you need to include this file. We could take a look at this file actually. If I right click on it and open it up, well, it's just an old C++ program, and well, it doesn't really mean much at all, and it's a bit more complicated because that program in itself will include other header files as well. So you can just go into deeper and deeper if you like. But so we won't be concerned with this. I'll just close it up here, just to know that this is really much the same as just in cutting and pasting all of that stuff right here. That's the meaning of the hash. It indicates to the compiler that we are introducing a source code file rather than typing the whole thing out. It makes it more flexible because that thing can be changed in future by the designers. Okay, but really the most important thing we've got here is this here, because this is actually our program. This contains our program. We always use these curly braces, open and close, and by the way, every line of the program has got a semicolon following it. Not in this case, because this one is what we call a function, and notice this doesn't have a semicolon as well. The header files don't have a semicolon at the end, but this is what we call a function. Now the problem is that we don't really talk about functions till about lesson 5, and so just for the moment it's a function. A function is just an isolated bit of code, and it can accept an argument into it, it can return an argument. This argument, the integer, will correspond to this being returned here. Void means absolutely nothing, so you could actually delete that if you wish, but it's not good practice, but you could. A matter of fact, you could have this in a different form. You could have a void here, means the function is returning nothing, and actually delete this line altogether. And if I were to build that, you'll see it still will, I'll just stop debugging, it still will build, as we can see here. Okay, so but I will just undo all that and return to where we were. So that's just really what you ought to do as standard procedure. Okay, now this thing here, using namespace std, just included into your program. It really is something which will deal with name conflicts in the future when they arise. If someone else is using a name of Edo in a program and you're using Edo in your program, then you can produce name conflicts, and this is just a bit of forward thinking, if you like, in order to produce name conflicts. Some people don't like it, and there is an alternative. So if I just copy this bit here and then I tag it onto here with what we call a scope resolution operator, the scope resolution operator just says whom it belongs to. So I need one on the cin as well, because then I can actually just delete that. Well, rather than delete it, I'm going to do this. I'm going to comment it out by putting 2 forward slashes, and that will take no further part in the program. Another way of doing some commenting is like this. You see this up here. This is your comment button. You may have to go to the options and put that on your toolbar, but I'll just show you how that works. You see, if I can actually highlight 2 lines and then comment that, and now that's different. You see, this is a special type of comment. I didn't want to show you this at the moment, but that's a way of wrapping up 2 lines of comment. It's a little bit tricky to type. It comes from C, actually. A little bit of a hangover, but it's a bit hard to remember what comes first, the slash and the and then this one here, to turn it off. So I'll just undo that. Sorry, that should have, I'm sorry, I need to highlight it and then uncomment it, and that gets rid of it. But the other way to comment those 2 lines would have been to do them individually, and then they would take no part in the program. So what I was just showing you was that you can actually do without this statement. So let me just confirm that by building the solution, and it still works. Well, I'll just confirm that by pressing clicking here, and then that will still work. Okay, now what else have we got in this program? We've got this thing here. Now, well, let me just undo all that and take it back to that. Now, and that we can get rid of all of that. Okay. Now, this statement here means input. If I actually run the program, now I'm going to be a bit cheeky here. I'm actually, instead of going to build it and then run it, I'm going to be a bit cheeky because I know the program is all right. It won't cause any errors. So I'm just going to run it straight away, which you can do, and that just does a build. And I wouldn't advise always doing that, but if you're sure, then you can just run it, and it will build it as well. But if there are errors, it'll cause a bit of a problem. But you can see here that after hello world, it's asking for input from the keyboard, and you will recall if I now press any key, it will stop the program. So now, if I were to remove it by commenting it, and then I build the program, then now watch what happens this time as I run it. You'll have to watch very carefully. Ready? Go. Push. You see, the screen appeared and then disappeared, and that's because this line here was asking for keyboard input and effectively just holding up the screen. So I'll put that back in. Now it's quite amazing that many textbooks you won't see that. And you know, you build a program, just flashes before your eyes, and what on earth's going on here? So that is a way of keeping the console on the screen. There is actually another way. What I'll do, I'll comment that again, and so it has no effect. And there is another way. You can actually go through well, I'll build the program first, and everything's fine, and then I want to go through the debug menu, but instead of choosing this, I can choose this, the Control F5 one, start without debugging, and you'll notice now that if I it will put this stuff here, press any key, and so on. So you can do that as well if you wish, but personally I like to just keep the see and get to hold up the screen. Okay. Next I will go on to show you where these files have been produced and what they look like.